Earth is not the best planet for life. The authors of an article published in the Astrophysical Journal are convinced of this. Using data from NASA's Kepler Space Telescope, these scientists studied over 2,000 exoplanets in the potentially habitable zones of their stars. What's most intriguing is that over 120 of these worlds are gas giants, each potentially having at least one moon. Surprisingly, that's where the greatest chances of finding extraterrestrial life lie. Not only could these moons have liquid water, but gas giants can protect them from cosmic radiation, provide a magnetic field, and even an atmosphere. In other words, everything Earth obtained with difficulty and great luck, the moons of giant exoplanets can have for free. There's just one catch. Despite the efforts of astronomers and the observations of the James Webb Telescope, no exomoons have been seen yet. However, in our solar system alone, gas giants have a staggering 131 moons, and many scientists believe that several of them could not only be cradles of extraterrestrial life, but could also be perfect worlds for colonization. In this video, you'll find out which moons could sustain more than just bacteria, what Earth farmers could cultivate there, and why a cold and gloomy world orbiting Saturn is more suitable for colonization than even Mars. In general, what could life be like on the moons of gas giants? Scientists have long believed that all the solar system satellites were like our moon, dull and lifeless rocks. However, some of them have surprised astronomers during exploration. In the early 70s, NASA's Pioneer 10 and Pioneer 11 spacecraft first explored Jupiter's moon Io up close. Their data revealed an anomaly: the tiny moon's mass was larger than expected. Typically, such celestial bodies are composed of water, ice and silicate, but Io is filled with silicate rocks and iron, making it the densest moon in the solar system. Io's thin atmosphere intrigued scientists even more, but its thorough investigation was hindered by the radiation belt surrounding the moon, which caused malfunctions in the Pioneer probe's equipment. Fortunately, in 1979, the Voyager probes rectified the situation. Their more advanced equipment finally allowed them to capture high-quality images of Io's surface, and the scientists couldn't believe their eyes. There were no impact craters on the moon. Initially, NASA thought Jupiter was pulling all the meteorites towards itself, but they soon noticed long trails in the images indicating volcanic activity. As it turned out, Jupiter's gravity and the gravitational forces from its closest satellites compress and stretch Io's interior, heating it up. As a result, molten streams of silicate magma mixed with large amounts of sulfur erupt to the surface. That sulfur covers the craters and the entire moon's surface with a toxic layer. Combined with radiation, it's fatal to any life form. However, beneath Io's surface, there are relatively safer places. As the magma breaks through and cools down, it creates what's called lava tubes in the rock, where water can be preserved and microorganisms could potentially survive. For example, on Earth, we have sulfate-reducing bacteria that process sulfur compounds and even pure sulfur during their life cycle. That's why they choose soil and water rich in hydrogen sulfide for their habitat. If we plan to colonize Io, we'll have to follow the example of these sulfur bacteria and hide beneath the surface, constructing underground bases far away from the volcanoes. Otherwise, there's a high probability that all the colonist structures, along with the colonists themselves, will be destroyed by volcanic eruption within a few years. Underground bases can also significantly reduce radiation hazards, but no matter how hard we try, they won't provide complete protection against radiation. Additionally, even the most shielded electronics of the colonists will malfunction, just like Pioneer 11. But is there a place in the solar system similar to Io, but without such terrifying radiation levels? Another moon with active volcanism is Triton. Precise data about this celestial body were first obtained in 1989 when Voyager 2 flew by Triton. Scientists had expected to see a dull, lifeless rock, but instead, the images revealed a complex topography. Moreover, in some places, mysterious dark geysers shoot straight up into space. All of this happens at a temperature of -235 degrees Celsius, which means we're dealing with cryovolcanism. Under such conditions, ordinary water burns its way just like lava on Triton's surface. Only bacterial spores in a dormant state, waiting for better conditions, could possibly survive. As for the underground water reservoirs from which the geysers erupt, we know too little to draw any conclusions. If we ever decide to build a base on Triton, we'll have to think carefully about reliable insulation instead of radiation protection. This could be achieved using local resources, such as blocks of local ice formed into a dome shape. Water could be extracted from it, and the fuel literally lying under our feet can provide the energy for melting. Apparently, Triton contains ammonia, methane, and nitrogen, which can even be synthesized into rocket propellant. However, the main obstacle to colonizing this moon of Neptune is the distance. It's 30 times farther from the Sun than Earth, and the journey there would take at least 12 years in the best-case scenario. Modern technologies do not yet allow for the transportation of the necessary cargo, materials, and food to such a distant place for the survival of colonizers. Even NASA's exploration missions to Triton are constantly being postponed. So let's be more pragmatic and return to the moons orbiting the nearby gas giant, Jupiter. Apart from Io, the Voyager missions to Jupiter's other moons greatly intrigued astrobiologists. In 1995, the Galileo spacecraft arrived there and sent back to Earth over 30 gigabytes of unique information. Scientists were particularly interested in Europa, as the Voyagers captured strange lines on its icy surface. Galileo confirmed that these lines are constantly changing, indicating they are nothing but cracks in the ice above a liquid water ocean. Scientists now believe that its volume is twice that of all Earth's oceans combined. However, the exact composition of the local water is still unknown. To take samples, we would not only need to reach Europa but also drill a well into the icy surface, reaching a depth of 150 kilometers. However, there's a simpler way to obtain a sample. Observations with telescopes suggest that Europa's ocean spills directly into space through the cracks on the surface. Water molecules form a long trail that a passing spacecraft could capture and collect samples from. Analyzing these samples would not only clarify the ocean's composition but could also answer the main question: is there life beneath Europa's ice? Astrobiologists speculate it could be organisms similar to the single-celled ones on Earth that withstand extreme conditions and inhabit even the Mariana Trench. High pressure, darkness, and cold do not hinder their existence and reproduction. Most likely, these would be bacteria like Paracoccus denitrificans, which demonstrate incredible adaptability. They can live in both oxygen-rich and oxygen-depleted environments, feed on hydrogen and sulfur compounds, and even thrive under hypergravity conditions. In the lab, they kept growing at an acceleration of over 400 g, equivalent to a super explosion. Unfortunately, humans are far from such endurance, and if we want to colonize Europa, NASA engineers will have to rack their brains. I bet you've already thought about an underwater city under the ice. However, to understand the feasibility of such a project, we first need to drill through Europa's ice and deploy robotic explorers beneath it. NASA is already testing a unique drone buoyant in water, which will essentially press against the icy crust. All that will be left is to drive the wheels, and the device will be able to traverse the entire moon from the inside. If conditions prove suitable, the next step will be constructing an underwater base to extract oxygen directly from the water. In reality, settling beneath Europa's ice is not an option but a necessity because the moon's surface is also highly radioactive. In just one day on Europa, colonizers would be exposed to radiation almost 2,000 times higher than Earth's average annual radiation dose. This would be enough to say goodbye to life within the next month. So if for some reason the underwater bases fail, the icy crust proves too insurmountable, or the water itself is toxic, we'll have to abandon the idea of colonization and seriously consider another of Jupiter's moons. Ganymede is the only moon in the solar system where radiation poses almost no threat on its surface. This is all thanks to its magnetosphere, discovered by the well-known Galileo spacecraft. Usually, such strong magnetic fields are found around planets, and not even all of them, but Ganymede, in terms of size, surpasses Mercury. It's basically an entire planet orbiting Jupiter. As a bonus, Galileo discovered an underground ocean on Ganymede. It seems to be a trend among the moons of gas giants, but there could be up to 4 of these oceans. They're believed to lurk in layer cake fashions, separated by ice layers. Most likely, they formed under different conditions, meaning that various life forms could inhabit each of them. In salty water, not only bacteria but also larger organisms could live and reproduce. For example, radiolarians are essentially plankton with an internal mineral skeleton made of silicon or strontium. Their size is not more than a millimeter, but in salty water there could be organisms tens of times larger. Artemia, a crustacean that lives in saltwater bodies around the world, can reproduce even without a partner. Usually, they lay eggs, but in extreme conditions, they become ovoviviparous. Artemia eggs can survive for a long time, even without oxygen and water. If there are no extraterrestrial crustaceans on Ganymede, its oceans could be populated with terrestrial Artemia. A paste made from them is so nutritious that it can replace meat, which is much more beneficial than spending a lot of energy on growing lab-grown meat. Besides radiation safety, this makes Ganymede quite promising for colonization. Moreover, there's another essential condition for life there. The first observations from Earth through telescopes revealed a thin atmosphere around Ganymede, but Voyager 1 did not confirm it. However, in 1995, with the help of spectral analysis, scientists managed to establish that Ganymede has an atmosphere containing oxygen. Undoubtedly, it's too thin to breathe or to retain heat. Therefore, the temperatures on Ganymede's surface reach -203 degrees Celsius. Yet, even a thin oxygen envelope on moons is a great rarity, and here it can be extracted, purified, and condensed for the breathing of colonists. In any case, on Io, Europa, and Ganymede, there are only isolated corners where primitive extraterrestrial life could thrive, and colonists will have to make tremendous efforts to compensate for the lack of atmosphere, radiation contamination, and other disadvantages. But in our solar system, there is one place where all these tricks are unnecessary, and it's an entirely unique celestial body orbiting Saturn. This gloomy and cold world may turn out to be the best place for life in the solar system. The passing Pioneer 11 and Voyagers couldn't even capture its surface hidden by dense clouds. To penetrate beneath them, a special mission had to be arranged. On January 14, 2005, the Huygens probe successfully landed on Saturn's largest moon, Titan, and it discovered not just clouds but something no satellite of a planet in the solar system has, a dense atmosphere. Moreover, like Earth, it primarily consists of nitrogen and disperses destructive cosmic radiation. But the similarity ends there. The moon's surface is not visible due to the formation of hydrocarbon smog in the upper layers of the atmosphere under the influence of faint sunlight, which doesn't allow rays to penetrate further. Therefore, eternal darkness reigns at Titan's surface. However, as Huygens found out, the atmosphere itself is very active. Unusual swirling winds blow there, carrying streams of warm air from pole to pole daily. As a result, dunes are formed in Titan's equatorial regions, just like in Earth's deserts, only the sand here consists not of silicate but of hydrocarbon grains resembling coffee grounds. Titan's landscape, instead of rocks, is composed of ice blocks which are almost as solid at a temperature of -180 degrees Celsius. But like other satellites of gas giants, there's liquid water on Titan in a subsurface ocean at a depth of 880 kilometers. Extreme bacteria similar to those on Earth could thrive here. However, this is far from the only hypothesis regarding extraterrestrial life on Titan. Rivers and seas of ethane and methane flow across its surface. On Earth, these are gases, but there, in the extreme cold, they're liquid. Astrobiologists believe these exotic water bodies could have given rise to life of a completely different type. In 2020, an article appeared in the Astronomical Journal stating that they discovered a carbon-based molecule called cyclopropanylidiene in Titan's atmosphere. That's quite strange, because such compounds are typically found in interstellar dust clouds, and Titan's atmosphere is too warm for it. Cyclopropanylidiene should just break down. There could be something unknown to science constantly generating this compound in such quantities that it's visible from Earth. Extraterrestrial life could be a suitable candidate after all. Similar molecules are part of DNA and RNA, which makes biological markers. However, life on Titan would have to find a water substitute for cellular metabolism, and the most surprising thing is that astrobiologists have already successfully modeled a membrane capable of allowing liquid methane to pass through. This is an azotosome consisting of nitrogen, carbon, and hydrogen molecules. It could serve as the foundation for truly exotic cryogenic life. It's not excluded that analogues of our ice worms that inhabit North American glacier are currently gliding across Titan's dunes. Moreover, on a moon with low gravity, they could be much larger. However, it's improbable that we could ride them as in the Dune movie. In any case, we'll soon receive news about life on Titan. In 2027, NASA plans to launch the Dragonfly mission to Titan. It'll be more than just a probe, it'll be a quadcopter capable of flying over the surface for extended periods, searching for anomalies, and landing to study them immediately. But even if this mission doesn't uncover any life on Titan, we should start thinking about future flights with more ambitious goals. Despite appearing cold and inhospitable at first glance, Titan is arguably the most promising world for colonization in the entire solar system. Yes, I'm including Mars here, which surprisingly falls behind Titan in several vital parameters, and here's why. Colonists of any world will require a significant amount of building materials for constructing a base. On Mars, NASA engineers plan to use soil and rocks, which offer limited options. Meanwhile, Titan boasts an unlimited supply of liquid and solid hydrocarbons, which can be easily synthesized into polymers and mold into any desired shape. Unlike Martian rocks, these lightweight and sturdy materials can be used to build habitats, laboratories, and greenhouses. Moreover, in the future, excess hydrocarbons could even be sent back to Earth. When considering long-term habitation, questions of food and water inevitably arise. Fertilizers for growing edible plants on Mars would need to be imported, relying on a fragile closed reproduction cycle. On Titan, however, the atmosphere already contains nitrogen, methane, and ammonia, fertilizers. This would enable the cultivation of vegetables in special greenhouses and even the creation of self-sustaining ecosystems with minimal risks. The main challenge would be providing warmth. Water is scarce on Mars, only found in the polar ice caps, which would require long-distance transportation. On Titan, water erupts directly from beneath the surface. Although it contains around 10% ammonia, which acts as an antifreeze, it could be easily purified. Hydrocarbon rivers would also serve the colonists well, as they could be utilized for hydroelectric power generation. Furthermore, there's no need to fear accidental electrical sparks near tons of liquid fuel since Titan's atmosphere lacks oxygen, making combustion physically impossible. On Mars, energy could only be obtained from solar panels, which would constantly need cleaning after sandstorms, all of this while wearing bulky space suits. Mars' atmosphere is not only filled with toxic carbon dioxide but is also extremely thin. The atmospheric pressure on Mars is only 0.59% of Earth's, but on Titan it's 1.5 times greater than on Earth. Therefore, you would only need a suit to protect you from the cold and a respirator with oxygen. It could be extracted in sufficient quantities from the subsurface ocean water. The main thing is to make the breathing reservoirs extremely reliable to avoid explosions. You could even populate Titan's subsurface ocean with cyanobacteria equipped with more powerful ultraviolet lamps and wait for them to produce enough oxygen. All of these operations could be carried out from a base, which could resemble existing concepts of Martian settlements, with the only difference being the absence of pressure variations and the need to protect against lethal radiation. Instead, the insulation should be more robust, not just for the comfort of the colonists, but also because humans and their equipment on Titan will generate a significant amount of heat. So much so that without proper insulation, both the base and the colonists would literally melt the hydrocarbon soil and sink into it. Besides, the most convenient transportation mode on Titan is not driving, but flying and swimming. NASA is already developing a special hydroplane that will be able to hover in Titan's dense nitrogen-methane atmosphere and glide across its oceans. But the most astonishing thing is that on Titan, you can fly even without special machines. It's the perfect place to fulfill humanity's long-standing dream of taking flight by just waving our arms. The gravity here is only 14% of Earth's, so a pair of folding wings could turn any colonist into a bird. However, even after all of this, Mars still outperforms Titan in terms of accessibility. It takes less than a year to reach the red planet, whereas the journey to Saturn's orbit would take a minimum of 5 years. Yet, if we want to ensure our survival as a species within the solar system, this is not such a significant drawback. After all, both Earth and Mars are ultimately doomed. In just a billion years, the Sun will begin to emit 40% more heat, causing Earth to leave the habitable zone. The water in the oceans will start boiling and evaporating. The accumulating vapor in the atmosphere will lead to a greenhouse effect, turning our planet into a hellish furnace resembling Venus in just a few thousand years. In 4 billion years, the Sun will turn into a red giant, expanding and engulfing almost all of the nearby planets. If Mars survives, it'll become the closest world to the Sun, much like Mercury is now, a scorching hot piece of rock. If our colony is there, it'll just melt away. However, after such an apocalypse in the inner solar system, the moons of the gas giants will flourish with abundant warmth and become far more comfortable for tens of millions of years. So choose now on which moon would you like to stake your claim.